box. Is it audible now? Is it okay? Okay. So I'll be this talk will be more about intricacies around Apache Iceberg before what was the challenges as a data engineer we faced during the before the iceberg journey or the Lakehouse journey. Last month, when after coming from Ankur's marriage, we had a small meetup from the college. Okay, from my college friends and the juniors from my college, they wanted to meet, and we had a conversation about the latest technologies and the tech stack, what is going on in data. So one of the junior who started working in IT for the last 3 years, he was saying, "Bro, I was working in software engineer for the last 2 years, and recently I came to the data engineering. But people in the data are more obsessed with the Lakehouse. And when I ask them about what is the new in Lakehouse, they tell about it. It supports inserts and updates. This is something existing for so long, and what is that fascinating these people?" Okay, this is something conversation went, and somehow I was able to explain him. Doing anything for a small scale is easy. Suppose building a web application for 100 users, 1000 users is good, but building the same application for the users of 1 lakh scale or something, that is very challenging, right? It's the same thing what Lakehouse is trying to solve as well. So I'm able to explain him. At the same time, I tried to recollect the problems which have been faced before this Lakehouse, and I'll go through. This is something from my first project where I worked. I'll go through those challenges. How many have been working on this Hive or something before 5 years during the 0.14 version? Oh, okay, nice. I think you can relate to these challenges which I will be going through. Little bit about me. I'm Sai Vineel Thamishetty. I work as a senior data engineer. Uh, I started my journey when people used to call as a ETL developer. There was no data engineering at that time. There was a as the data ecosystem is matured, there is not only the ETL pipelines. There is a lot about the governance, security, and there is a lot of other challenges, lineage. All these things need to be covered. So they converted the ETL developers into a data engineer now. Currently, I'm living in Bangalore, and currently I'm working in Walmart Global Tech for last 5 years. I deal with mostly with the assortment systems as well as investigative fraud analytics in the area of retail domain and the insurance domain in the Walmart. None of the presentation which I am going to cover today is related to the Walmart. Somehow in the last moment I came to know I need to take some permission before I present something stats about Walmart outside. So I dropped all of those. Okay, I'll covering what are the challenges I faced before Lakehouse and how the life during the Lakehouse, and what is the GCP support for Lakehouse at what is the current state of that particular GCP on the Lakehouse journey. So this is my first project which I worked on. We have a printers as a service business. I work for a client who manufactures laptops as well as printers. They have a printers as a service business where they install the printers on your on-premise, and they monitor your printers remotely. These printers have IoT devices which emit the data, and we have a lot of organizations spanning across the world. Those we get the data for API gateway. We have a API gateway, and behind that API gateway, we have the servers. These are Windows servers. I don't know why they have used Windows, but it is the Windows what we are using at that time. All the data will be coming to the 17 servers. We call it as a telemetry servers. Okay, once the data is in the telemetry servers, we have agents installed on those servers, and which will continuously push the data into the data lake. It creates the timestamp based on the time we got the printers. This is very small portion of the entire application, and we have a sales DB where we have the details about what printer is installed in the which system, so that we can correlate with the data in the data lake. And this is the time where we were writing MapReduce programs for all these particular data processing steps. And it was Hive was in a we were adopting Hive, but there was a time where we were moving out of MapReduce, but we need to write MapReduce programs where we have written most of the code there. And the first challenge, it was my first project on the data ecosystem, and I have developed a job. I have written a MapReduce program. I've scheduled it. I tested it in the dev. Everything looked good. I got a sign up from a lead, and then I scheduled the job. And the day it went to prod, I got a call from a lead saying, "You have corrupted the data. What did you do?" Okay. Then I tested it very well. I reviewed with couple of older colleagues as well. The problem is not with the data. The program which I have written. Program is good, but the thing is, I scheduled the job at 12 a.m. UTC, where most of our jobs are there. So I took the same pattern I scheduled at the same time. Thing is, there are two jobs running at the same time. So there is when we are using Hive, there is nothing kind of an way which lets the job know there is already a job running on this particular table. Hive is kind of an storage layer. It tells us where the data is, but it doesn't block. Most of the schema inference will happen at the read time. While writing, it doesn't block you from writing the data into the same storage. Okay, so we have the two jobs writing at the same table. So this is the big problem, and it corrupted the whole data. So we need to process the older data which was stored earlier and the new job data as well. So this is the pain point. This is the first challenge which I face with the Hive. And the next thing, we have now new printers deployed. As the sales team, they started deploying the new printers, and they asked us to collect the new data as well. Okay. When we have the printers deployed, new printers will always come with a new version of the IoT devices, and these IoT devices have the new table, new schema which it is generating. The old data which we have is not in matching with the new schema, exact schema. There are some new addition of the columns. There are columns which have been removed. So the thing, we can add the new columns, but we also need to process the whole financial year data. Every time we have a new printers, we need to process the whole year of the data, and the data is very high. It's every minute you get a data from that particular IoT device, what is happening in that particular system. So we need to process the whole data, which again takes, we need to hold our current jobs, we need to process the older data, and we need to bring all those into normal state every time we have a new printers. So there is kind of a no schema evolution concept at that time. Might be it is having little bit, but it is not matured enough at that point. And now there was our business partner who was on leave, and she was not reviewing the reports during our leave, and she want the status of the reports at that point of time, not today's data. So what happens in this case, we need to process the whole data which is till yesterday or till last week when she was not available. The current data is not useful for her because she want at that particular point of time. There is no concept of time travel or something at that moment, and so we need to process whole data at that time for that particular duration, till that duration, and we need to reprocess the whole data. This is the one of the challenge we are facing. And then the team is expanding, business team is expanding, and they have now reports and sales team and the marketing at the regional. They were having the regional level. Now they are moving at the city level. They want to understand the reports at a city instead of at the regional level. So what is happening at this time? We have partitions based on the region. Okay. So how Hive used to work is, whenever you have a partition on that particular region, those will only work when you need to repartition if you want to change the new partitions. I mean, currently you have Hive table created on the partition of region. You need to process the whole data if you want to create a new partition at a city level. It is easy to just change the city and you can get the data, but you will not be utilizing the all the powerful query. You will not be, your queries will be even slower. You are not utilizing the complete compute, what I could say. And I need to, there was a limited partition support at that time. I think now Hive has matured a lot. We have, I think, release 4 which is going to happen. The community is still active, where I checked it yesterday, and I was surprised that people are still using Hive with all these new features. And then these are something challenges, and along with this we have regular tasks. If you write the data directly to the folder structure, where you are not interacting with the Hive table, Hive meta server, Hive meta store, that data will not be coming up when you query the tables. Okay, might be you will be you can recollect the this particular first statement, MSCK repair table, right? I think all the people who have worked at that time might be using this multiple times. The person who loaded the data, they say I have loaded the data, but the person who is querying the data, they say I'm not getting the data. Most of the times the mistake is they might not be running this MSCK repair table. Then a lot of other things, you have compaction, which is still a challenge, and Hive meta server goes down a lot of the times. You need to restart those servers and your partitions and deleting the data underlying partitions manually. All those things were different kind of challenges. Okay, so far to summarize, what are the things I have faced? These are the major challenges which I was facing as a data engineer, and most of you as well. The smaller updates were very inefficient. We need to process the whole partition at that time if you want to process the data, and if the multiple jobs are running at the same time, you should be conscious of taking care of that. You should not schedule the jobs. Might be you need to maintain a different list where you list out those jobs, and you need to know the physical layout of the table to use the partitions effectively. If you don't know what is the table structure, you cannot use the table properly. It will do a full table scan, and if you don't run that MSCK repair table, or there are other parameters, if you don't tune, you don't know table statistics will not be updated in the Hive meta store, which your query engines might not be able to use them, and schema changes are also not smooth. And is Hive that bad? So far I have told a lot of bad about Hive, right? But is it that bad? Actually it is not, I feel. At that point of time, this is the savior for most of us. If we don't have this Hive table at that time, we might be needing to need to read the entire data at that time. But the partitions which were provided at that time was actually bypassing those most of the things, and it allowed us to store the data in multiple file formats. It allows Parquet, ORC, Avro, CSV, whatever it is. It used to allow all of them, and we were updating the atomic partition atomically, and this is something followed in the entire industry at that point of time. This is the only thing, I think, tool which is available at that point of time for all the big data systems. Okay, so far we have covered most of we recollected most of the things during the Hive journey. Any queries? Okay, we'll be going through Iceberg. I'll cover a little bit basic stuff about the Iceberg, how the table layout is, and what is the reason Iceberg came into existence, and this.
How many can recollect all the old days, and if you have worked more than 5-6 years, how many of you can recollect all the pain points which used to be there? Please raise your hand. Yeah, it's very at least 50%. So those who have worked enough, they know the pain which data engineer, or at that time I don't think even the data engineer term was there, very famous. But yeah, let's see how Iceberg helps now.
Do you want to recollect something which I missed as a during the Hive journey or something? Okay, we'll go to the Hive. All the Lakehouse formats, whether it is Apache Iceberg or Hoodie or Delta, all these comes under an open table format. Basically, those format doesn't have any kind of an engine or something. Those helps us in the laying out the specifications of how we need to store the data. Then it's up to the query engines who query the data to use those particular parameters. Suppose we store the data and we store the metadata of the underlying data, and we tell different parameters which Iceberg supports or whatever the Lakehouse format supports. We fill those parameters in the metadata in the form of different file formats which they support. Then it's up to the query engines how they query these particular things, and every layer of this particular table format is open basically. That's the reason I think they have named it as open table format. And the one thing, it allows data to be stored in any file format, Parquet, ORC and Avro. And yesterday I was seeing an RFC in the Apache Hoodie where they are allowing pluggable file format. It's not only these three formats are different. If tomorrow there is a new format coming in, it should be kind of a pluggable thing so that it supports the entire all the operations which is being used. I think this is the first time they come up with the RFC. There are no players which is available with that solution. And specifications. Yeah, as I said, these file formats actually lay out the metadata specifications, and they also support few libraries for different languages. Suppose if you see the same Iceberg, they have libraries which connect with this particular file format in the Python and the Go, and they the same community supports these libraries as well. And it's open to all query engines. We have E6, we have Trino, BigQuery, and what we call Star Rocks or whatever it is. It is open to all query engines because at the end the structure of the file is known to everyone. So query engines can adopt to those structure whenever they connect to these uh, files. And the same community actually also is contributing to the supporting libraries in PyIceberg and Iceberg Go, along with Apache Spark and Apache Flink. Whenever you use the Apache Spark, all the connectors which were developed is in the same community. So most of the times all the features or the specifications which were introduced by Iceberg will be natively supported by these tools because they do all in parallel mostly. So whenever you use this Spark, most probably all the parameters which you have defined during your creation of the tables or something, it will be utilized with these tools. But if you see the same thing with the other ecosystem, like if you see the BigQuery or the other query engines, most probably you need to take care and you should do an due diligence of checking whether this particular parameter is supported by this particular query engine or not. Otherwise, if you are not aware of that thing, you might be writing the right format. Suppose let's say while writing the table you want to use this MOR for the deletes, okay, but if the query engine itself is not supporting, there is no use of writing in that particular format. So these kind of due diligence we should be doing, and whenever you use this Spark and Flink, there is no you don't need to worry about that because by default they support it. And this is the very low level structure of this particular Iceberg table format, and whatever operations, whatever you are seeing, all are related to this particular metadata files at the end. Might be the compaction or whatever the security layer of this particular thing at the end only happens with this particular file format. If we are aware of this, what columns come to in different layers, actually most chances you will be able to debug most of the issues, the compaction issues, whatever we are facing, and all those things will be related to this particular file formats. We have this multiple layer. The first thing is the catalog layer. Catalog is something different from the Iceberg, where they basically catalog is if you see the Iceberg ecosystem, they want to be just a table format. They don't want to maintain the catalogs how the query engines want to use. So they were limited to this particular metadata layer and the data layer. The first, if you see the underlying layer, is the data layer. This is where you have Parquet files or ORC files or CSV files. Those all come under the data layer. And then on top of that, we have the metadata layer. We have manifest file, which actually stores all the information about these data files. What is the min value of this file? What is the max value, number of rows, and all these kind of average values. These kind of files will details will be stored in the manifest file, and the manifest file goes to the manifest list. Manifest list actually stores the snapshot of this particular files. There is a concept of snapshot in Iceberg which actually helps us in the time travel. So in the time travel, what happens? You can point back to the data. Suppose you have the problem which I have mentioned earlier. Suppose if you want the reports which are at the yesterday's point of time, you can easily go back just finding the snapshot ID. So all the data you will be able to retrieve with the help of this manifest actually. And if you see the metadata file, that's hold the information about this manifest list which holds the snapshot data. And the first thing is, and the topmost thing is the catalog. There are many catalogs. I think there is a war against this catalog as well now. There are multiple players. If you see, actual catalog is the main. Whenever a table interacts with the, whenever a query engine interacts with this file format, they first go to the catalog. They check what is the current metadata version of the file I need to be using. Okay, any query engine or external systems trying to connect to the file format will go to the catalog, and catalog they try to find the right metadata file, and it propagates till the data files. We'll go through small events. What happens when you create a table in the Apache Iceberg, and what when you insert and when you merge and delete operations. These 4 operations we'll be doing. And the first thing, if you see, we have a catalog. Whenever you define Iceberg ecosystem, you create a catalog for that. What catalog you should be using? Let's say we have an Iceberg catalog. You have created a table here. Create table stat, and you are partitioned by the hover. If you see here the file structure left side below, every table whenever you create in Iceberg, it creates there two folders. Okay, one is the metadata folder and one is the data folder. Metadata folder holds the information about the data present in those files. So as we have no data, we just created a table, so it has just created the metadata file. If you see in the previous thing, we have two more layers, right? Manifest and the manifest list and the manifest file, right? Those two are not available now because we don't have any data layer itself. We just created the table. Now we have inserted the record. Let's say we have inserted one record. If you see here under the metadata, till now it was only v1.metadata file. Now it created a v2.metadata JSON file, and along with that it created two files, snap and the actual avro files. If you see metadata file, manifest list and a manifest file, these are the three different files. These all three are created in the v2. In the v1 we have only table, so we don't have these files. v2.metadata metadata is the JSON file, and remaining two are avro files. Avro files are mostly row based, and this will be faster than for the row based reads. We have a snapshot file created for the manifest list, and we have a file created for the manifest, and we have a data file which is under the data folder under that particular partition. When we created this partition, we have used the hover folder, and we have the file created parquet file under the data folder. So far it's clear, right? All these four file formats. And now let's do one more operation, which is the merge or offset on this particular table. So far we have the snapshot 0, S0 and S1. Now it created one more snapshot. So every operation you perform on this particular tables, it creates a new snapshots. In some cases we can use tell this as a benefit of using Iceberg. Sometimes it creates a problem of vacuum and compaction, where you need to get rid of these older files which are generating higher, which are occupying more space as well. But if you see, it created a one more snapshot file. It has a manifest list and a manifest file and the two data files. If you see here, now it is pointing to the v3 metadata JSON, which is the new metadata file created, and then one more snapshot file and one more manifest file. And this holds information about data files. I am doing a merge operation, which is update and insert. Insert is something new records. So it all went to a new folder structure based on the partition. If you see here, it created one more folder for the partition, and the merge is something updating the same records. Okay, so it created under the same older table itself. And the reading a table. So far we have done different operations. When a query engine connects to this particular table, how does it read the table? What is the flow it takes in? As I said earlier, it will first go to interact with the Iceberg catalog. Okay, it goes to the Iceberg catalog and finds the right pointer. What is the metadata file I need to use? Then it goes to the metadata file, and in the metadata file, it will try to find the right manifest list. This is very simple operation. I have done only one insert and one upsert. You will be seeing only few files, so it is connecting to only two manifest lists there. But think about the operations where you have like hundreds of transactions happening on this particular table. You can think about how many files it will create and how much space it will be occupying. And it reads from manifest list what is the manifest file you need to go, and then it reads the data file and it returns back the data. Okay, so far we have went through the different what is the approach Iceberg is taking while inserting updates and while deleting, and how it solved my problems. I will tell you. Well, the first thing is the time travel. As I said, snapshot. Every time you create a transaction on this particular table, it creates a metadata file which points to the files at that moment, right? So if you want to go back, you can always go back to the point of time where you want to read the data easily. There is a table by default. It gets created in the catalog if you are using Iceberg catalog. I am not sure about others, but there you can actually find all the right snapshots and the timestamps at what moment the file has been written, and you can just query from the snapshot. You will get the data at that moment. So I don't need to rewrite or reload all the entire data when I want to go back the reports at that particular moment. And ACID transactions. And this is the most important feature I could say in the entire Lakehouse journey. uh, we might be having only less number of updates or commits, right, every time. This is the challenging, very challenging thing when you have tables with terabytes of size and petabytes of size. Doing a small updates on those tables will be very hard when your partitions are very bigger as well, right? So because of this Iceberg, you will be able to do all this CRUD operation, all inserting, updating, deleting, all these things in very shorter span, instead of processing the entire data. This has actually revolutionized, I can say, the entire Lakehouse thing, ACID transactions. And the next we have is hidden partitioning. Earlier, the data engineer need to know the partitioning. Whenever I write the queries on this data table, I will go through the table structure. What is the partitions it has there, and I need to understand each and everything of that particular, how the table is created, so that I can write my queries effectively. But now with the hidden partitioning, where you don't take care of that particular, you don't need to know whether the partition is available or not. If you write a query, if the partition already existing, it will automatically take care of that. And even if you create a partition on the timestamp, if you don't use the right format, suppose let's say you have created a partitioning on the date folder, when you are filtering on a month, it will not be taking care of your partitioning earlier Hive. So what happens with this Lakehouse is, you even if you take the partition on the date column, and even if you filter out by based on the month, it takes care of partitioning. It doesn't need to be in the same format if you want to make use of that. And the next thing is the schema evolution. So whenever there are any new columns, because there will be always new columns coming in, and the data is growing, and the sources systems are expanding, and you will always have the change in the columns in the source, right? You don't need to process your entire data whenever you want to change the schema. The older data will be as is, and the file format helps you in that particular adding these new columns. As I said, like think about the transactions where you have thousands of transactions in the same Iceberg table, or very high scale. The data is always replicated, and you have a lot of snapshots created. Uh, so what is the solution these table formats are proposing? This is something existing very long in the hoodie. So we have two kinds of tables. I think we had a discussion during the panel discussion as well. We have two kind of tables: merge on read and the copy on write. During the copy on write, what happens? Okay, I think I have one slide. Okay, during the copy on read, copy and write, what happens? Every time you write a new transaction or any change in the data, it creates a copy of that particular file. So whenever you are writing the data into the table itself, it is creating a new copy. It means that your writes will be slower. If you have data which you occasionally use, or which is not latency specific or something, you have a lot of time, then you can go with the copy and write, where you have write the data very less frequently. So it is okay for you to spend time while writing itself. Okay, this you can see the table there. The pros of this is the faster reads. Reads will be faster because you are taken care of merging the data or creating a new file at the right time itself, and the writes will be expensive. It depends on the trade-off, what kind of solution you are trying to solve, which table format you need to be using. And we have a merge on read. What happens here, while reading the data, you merge the files. Okay, if you see here, I have the file 003 parquet, and I have the same file there after applying a delete. Okay, when you delete the file, if you see there are two files created: delete 001.avro and the file parquet. The file parquet has the data of which you need to delete, and the delete has data about what is the file you need to take care and what is the position of that file. There are two kind of ways you can handle this, even on merge and read. In the merge and read, here if you see, you are specifying on which file and which position the file data is, you need to be deleting. It means that your query has read the file and it tried to find the position and the file also, because before writing into the delete file, it need to know, right, where the file is and which location it is. So it is reading the file. I don't have that slide, but there is a one more kind of delete which is called as equality delete. What happens in equality delete is, that is for the even faster write operations. Okay, where you don't specify the file position in the file, you just specify the id of that particular file. Id, suppose in this case it is 3, so whenever you get a id 3, just delete it, so your writes will be even faster here. But while reads, it will be again, it based on the trade-off you need to take, what kind of delete strategy you need to take. We define all of these particular parameters while creation of the table. And what is the delete operation you need to take during the delete, what kind of approach you need to take, and during the read, what kind of approach you need to take. And this all depends on query engines to read them. If though your query engine is not supporting, as I said earlier, the even if you write these kind of techniques, it will not be useful. And at last, I said Iceberg is very good so far, and it is solving all of my problems. But at the same time, there are challenges here existing. I listed only a couple of challenges which I went through, but there might be a lot of challenges. Recently, when I was reading the problems which Iceberg is going to solve in the next year, there are a lot of things actually which were even in the roadmap, but which were not solved as of now. The first thing is the security, because growing regulations in every country, we require security at a row and columnar level as well. We have a PII information in the same table, and where you cannot duplicate the data just for the sake of securing one particular column. So you might need to replicate the data if you don't have a solution here. But natively, it is not. Iceberg doesn't support as of now securing a column and the row level details. So you might need to go with the catalog approach, where these vendors are providing that. But if you have the data at the same layer and there are multiple query engines reading the same data, again it's a tough. All those query engines might not be supporting the kind of security levels what you have written in the catalog, right? This is then one of the challenge. And operational overhead, like clearing of the snapshot, we call it as a vacuum, and optimizing compaction of these files, and it is still existing. And integration challenges with all these external systems. I think this community is growing now. I think in the very short span, you might be having at least the small challenges solved off while integrating with the different system. But these are something which I have noticed. Okay, I think so far it is clear about the Iceberg. Anything? Yeah, sure.
So this is regarding the hidden partitions.
Hmm.
So in the hidden partitions, while you are writing a partition, let's say a timestamp,
Hmm.
Does it automatically make the hidden partitions when you are writing the partition, or in read it is intelligent enough to combine all the partitions together to, let's say you are querying for a month and your data is partitioned on the basis of timestamp.
Hmm.
So does it automatically merge
Yes, yes.
everything together while reading, or while writing only it is?
It will not merge basically, but it will read. Suppose if you have given a date, you are given a timestamp. Let's say day basis. You have a folder structure on a day basis. Suppose if you want to use the on a month basis, earlier what used to happen is it will read the entire data and try to filter out. It will not use only that particular month. Now what happens? It will only read the days belonging to that particular month, and it takes care of that. Earlier you need to mention, even if you mention, it will not be taken care of because that was not supported.
This can be supported by all the query engines that work on top of Iceberg.
As I said, right, nothing is very rigid here. It all depends on the query engine whether they have implemented that particular. We as a table format, it provides the specifications. You store in this way. These are the specifications which you need to follow. If you use the query engines like Dremio or something, which are more dependent on this Iceberg, they implement it very fast. But other query engine, you need to look at that what parameters they are supporting.
I will give you an example. So in thesis data that we started looking into it, there was one client jet order, liquid clustering, all this type of things. So even as a querying engine, you have to evolve, right? It's a specification that they are specifying. Okay, that you don't need to just look at that particular partitions. We are coming with something else. Where you don't need to be very rigid about your partition. But as a querying engine, you have to start supporting it. So querying engines, their business is like that only. They have to be performant. So they will read the specifications. So even ELE6 data, we read a lot of articles, all the open PR and all those things, that what is coming, what is not coming. And at same like us, other querying engine will also do that, right? And with times they will start supporting it. So it depends upon the ecosystem that we are trying to build. It's all the specification. Yeah.
In the merge on read, you when you get the data, you are kind of deleting one like the record using an Avro, and you have one more file which is like the difference of the current, like let's say you have the current updates as a new file, right? So this difference, how much how much compute does it consume when it makes this difference with the new and the old data? So is that a blocking point where you kind of compare the hashes of, so what happens? Is it generally faster to, like, query it
For querying, you're telling during the querying on merge and data?
during the merge operation? Is it more time taking? Does it take a lot of
It
time?
happens. Do you want to take this?
Okay, you are asking when we are creating a merge and read tables, what is the compute capacity it utilizes when I read?
It's like you are doing copy and write. So in copy and write, you have another pointer to the new one.
Yes, yes.
But in merge and read, you have to have the difference right there
Yes,
when
yes.
you are reading. So does it lead to too much like time?
Yes, yes, it adds the latency. That is the reason. Suppose if you have reports which need to be really faster, then you should definitely use for the COW, because which will be faster. But again, it comes with a trade-off, right? If your transactions are very high, it keeps on recreating the same data, then it will be a problem again. So it depends on the use case specific, but it takes compute when you compare it to the COW. If you don't do the compaction well or these kind of things, it will be even slower. If you have lot of delete files, your time grows exponentially, I could say.
And see, COW and MOR are not very new concept. Those who come from computer science, see, this is a very old concept. This is the way of specific, right? Copy on write, you take a decisions what you want. You want to be faster at the write level, or you want to be faster at read level. It depends upon your use case, your business use case. So MOR, obviously, it's a merge on read, right? So where latency will be created? Latency will be created when someone is trying to read it. So it's not like a only open table format or has introduced all these things. COW and MOR is coming long back from the Unix concept and all those things, right? So you have to understand where I want to add latency. Do I want to add latency at time of writing it, or I want to add latency at time of reading it? It's not a new concept. It's just that open table format, and particularly Hoodie, they started with it, and they think that okay, in streaming, can we come with MOR? Because most of the streaming use case is like, I want my data to be loaded in this particular SLA. So they are like, I want to fast my process. But is it, if you think it intelligently, is it that much fast enough? Obviously, if you write into MOR, some querying engine has to do the merge. There the latency is being used. But they will think that, okay, I want to do marketing, I want to be on top of something, make an impact, right? Make an impact that I'm better than this. So obviously they will make some decision and they will say that, okay, we have introduced MOR streaming very, very fast. But when you are trying to read that stream data, is that fast enough? You have to understand. Then people will come up with like inline compaction, which Hoodie has done. Obviously, you can do it. It's not like think about a system design perspective, like operating systems. If you do inline compactions, how much better you can do it? For sake of saying, we can say that okay, inline compaction, we are doing it. But with till now, all the compaction that I have done and I have seen, all the external agents, I used to call external agent, like my Spark jobs, which used to do compactions on batch pipeline, was much better than any inline compactions. So it depends. It's the trade-off, and people are trying it. It's not like an NPR problem. People are trying it. They will succeed big times. But right now, you have to take the trade-off. Yeah. Right.
Okay.
Make it little faster.
Yeah, sure. I have only few slides. And so far, I think at my workplace we use Google Cloud a lot. Okay. Recently, and we use Apache Hoodie a lot. Okay. But recently, when this S3 announced these S3 Iceberg tables, and then there is something curiosity among us, let's try or do a POC on this kind of Iceberg, and that is where we landed upon. I'll go through those details, and then it's still in the pre-GA, so you cannot use these particular tables or not production ready basically. And I could say they released it hurriedly because of the competition. I think so, because I have very less features I could see which are in the pre-GA round. It was released in October last year. Usually they take around 6 months for the production availability. Might be I can expect in the next month or so for the new features in the Google Cloud. So when do we always we speak about open source when we think about Lakehouse file formats, and we always try to use our query engines which are also open source, and sometimes which supports all these file formats. But when to use these particular Iceberg tables provided by the cloud provider? Should I use it, or it is again their marketing strategy? So actually it depends on your use case. If you have a less team and you have less expertise in the maintenance of this particular table, then I think you can always prefer these kind of cloud providers who actually uh, indirectly actually they are again tying you up with the vendor locking in some cases. Suppose might be Vignesh has covered in the first part, again this is a catalog strategy where they are storing the catalog in their own internal catalog store where it is not clearly exposable for us. So you can use these cloud providers, but when you have this kind of challenges, you need to maintain these particular tables if you use the open source, and you need to don't want to maintain the catalogs explicitly, and you have a you don't have a support team which is more dedicated for these particular tables. You can use this. These are the main big data services which I use the most. Okay, the first thing is the data proc. This is similar to EMR cluster what we have in the AWS. Okay, you can create the clusters on the fly. I think when I started my journey there, it was like we used to have a very big persistent cluster. It was around 2 petabytes of size at that time, and most of the big players were Hortonworks and Cloudera at that time. I don't see those names nowadays, but we can create now ephemeral clusters in the data proc. Data proc is the service which provides us creating these clusters on the fly and delete it. It takes hardly 1 or 1.5 minutes to create the cluster of any size, usually as so far as on. And then we have a cloud storage. This is similar to S3 buckets what we have in the AWS, and all the services which I am covering here, these are being used by the Google products. If you see the maps, if you see the YouTube, all this analytics, all the real-time analytics, whatever you see in Google Cloud are actually, I read an article where Google is saying they use this data proc for their processing. And the BigQuery is a query engine where you have, you can create two kind of tables where completely managed by the BigQuery, by the Google Cloud. And the other thing is where you have a file stored in a cloud storage and you want to read them in the query, BigQuery. So it is kind of an offering a full-fledged data warehousing solution along with query engine support as well. And this is the BigQuery is being used, the backend of all these Google ads and the YouTube analytics, and all these are powered by the BigQuery. So it is something tested at very high scale, I can say, and so far I could say I have seen no performance issues in the BigQuery handling any TBs of data. I have a queries which runs on TBs, scanning the whole TBs of data, but it happens very fast actually. And the next, BigQuery is also is proprietary. As it's a proprietary, in the backend it uses a Google file system called Coalesces, which is more internal to Google, and it is internet. It is not an open source, and it is uses a file format called capacitor file format. It is nothing. It's not Parquet or ORC in the backend. And next is the BigLake. Sorry, I couldn't get this logo for that BigLake because I couldn't see in the Google documentation as well anywhere in the thing. And this is the BigLake, is something released a couple of years back, and this makes unified data platform. I think we have similar services in the AWS and Azure as well. You might be having tables in any of these cloud providers. This BigLake can create a connection on those connections, and it takes care of connecting all these particular cloud providers in the backend. As a developer, you don't need to worry at all. You just create a connection object which takes which has a proper access particular tables, and you read the tables as those are in the Google Cloud or in the BigQuery itself. So automatically it will figure out what is the table in which cloud it is, and it will make the connections underlying, and it will read the data. So how GCP handles Iceberg tables? There are two kind of ways how GCP handles Iceberg tables. One is natively supported by BigQuery, which takes care of end-to-end processing, end-to-end life cycle of the Iceberg tables, but the creation to the deletion. And the next thing is the BigLake external tables. Here your Spark might be creating an external table in the Google Cloud. Your Spark engine will take care of writing of that particular table and everything, the specifications, all these things. But here using the BigLake, you can create a connection from the BigQuery to that particular data store, and you can read in the BigQuery. Okay, here BigQuery just acts as a query engine, I could say. Underlying everything, the connection creation and everything will be taken care by the BigLake. So connection objects is very crucial. What I found during my POC, whether it's an native iceberg tables in the BigQuery or external iceberg tables which were stored in the Google Cloud or S3 buckets, wherever it is, you need to create a connection object. Connection object takes care of all the different kind of security and the access related issues. And discovering of those particular tables, if those are existing in the different cloud providers, will be taken care by the connection object. And it is something very crucial. I'll cover about it. Connection object support. The first thing I can say about the separation of concerns. As a table, when you create a table should not be taking care of the security access, aspect of the data it is storing. So it is dividing the security. All the security will be taken care by the connection object, and you just query as a developer or the data engineer or the BA developer. You just write your queries on this particular table, or you create the tables. Connection object can be reused across all your tables. If you create one connection which is having a proper access to your data stores, that is sufficient for all the tables creation. And the least privilege, so if you have the same key, if you maintain the IAM access or the for the underlying data sets as well at the table creation level, it is very hard for you to manage the access for multiple tables. Suppose tomorrow if you want to revoke the access for a data location, you don't know what all tables it is using and what all service accounts it is being used, and it's hard for the maintenance. And the least privilege come into picture. You can provide the minimal permission for a connection object. Suppose if there are few tables which require the right access, then you can provide the access higher level of access. So it helps us in the providing the concept of least privilege and the centralized management of all your data access and audit trail of how many times this connection object being used and how many tables you have been querying, how many times you have made a call to the external cloud provider, and because it all takes care of in the underhood, like creation of this particular clients and everything, right? So all this will be covered using this connection object. And this is a comparison of the BigQuery native iceberg tables and the external tables. If you see the managed iceberg tables which were provided by Google Cloud, the entire you will have a more control if you have a BigQuery managed iceberg table. Basically, it's trying to fit it is trying to make you use of the BigQuery, I could say, instead of providing keeping you self managing the right iceberg tables. And external tables, it doesn't have any control. It just uses for the reading. And the write axis, you cannot write the tables for the BigQuery external tables. You can only read it. And the life cycle creation and deletion of the tables and everything. When you delete the data for the BigQuery, it takes care of deletion underlying data as well. But if you delete the data for the if you delete the table for the external tables, it doesn't delete the underlying data. It only deletes the table in the BigQuery. And the metadata is managed completely by the BigQuery metadata store catalog, which stores which takes care of entire metadata. And if you are using an external iceberg table, you need to take care of your metadata by your Spark engine or something. And then format management, how the folder structure should be stored and everything. You have more control in the managed table than in the external tables. I think I've covered in everything.